All right, hello, Algebra 2. Welcome to section 11.4. We're going to be doing more probability. So remember, probability just means like the favorable options out of the total options. Um, Today we're going to learn something called conditional probability, okay? And it just kind of puts a condition on the probability. So it's actually going to change, mostly it's going to change the total number, but also probably change the favorable number too, I suppose would be accurate to say. So like, you could look at, like in this set of guitars, we've got like different colors and different types, acoustic and electric. So you could say like the probability that a guitar is acoustic, right? So that would just be all the acoustic ones out of the total guitars. But then you're going to say like given that. So you're going to say the probability that it's acoustic given that it's tan. Okay. And so what'll happen when they say given that like that is now you're going to look at just the tan ones when you're doing your probability. So your bottom number will be just the tan ones. And out of those tan ones, how many are acoustic? So it's a little bit goofy, but we'll do some examples and hopefully it'll help. We're going to use these things are called two-way tables where we divide the information up into different like categories. And so we're going to do conditional probability 2 days, today with these tables and then tomorrow with something called a tree diagram. Okay, so condition probability is a probability an event will occur given that some other condition has already happened. Okay, so you're going to hear this given that a lot. And so like this is probably the best thing maybe to write down is just this example. So they'll write it as probability of rain, line, cloudy. Okay. And the bottom number or the line means given that. So this will read probability that it'll rain given that it's cloudy out. Okay, and so what'll end up actually sort of happening is your bottom number will be given that it's cloudy means we'll look at all the cloudy days here, and then out of those cloudy days, how many days did it also rain? All right, and that'll be the top number. All right. And the way I explain this is actually with life expectancy. So like your life expectancy, believe it or not, actually changes with time. So like the probability that you live to be 80 years old, let's say that that is just 55%. Like 55% of people live to be 80 years old. Okay, but as you get older, your chances of making it to 80 increase. So as an example, probability you live to be 80, given that you're already 70, is probably higher. So in this case, you'd be looking at all the 70-year-olds and how many of them made it to 80. And let's say that that's like 65%. Okay, so I'm going to see if you can make some sense of this and say, how about this last one? Probability live to be 80, given that you've made it to 79. Pause the video and just take a guess. There's not a right answer. There's I actually know. Well, there probably is, but I don't know what it is. But just take your guess. So the answer is it'd be higher, right? It'd be like 90, 95%, right? Because you've already made it to be 79. So probability you make it one more year to be 80 would be really high. So probability live to be 80, right, changes when you put these conditions on it, right? And that's what a conditional probability is you put those conditions on the end of it. Okay. So I think it's important to understand, like, given that just means like that this thing has already happened, that you already made it to 79, you already made it to 70 or whatever it is. All right, so let's do some examples. Um, so here's a two-way table about prom, and I just made this up obviously, but this is like how many people went to prom. Okay, and so there is 50 sophomores and 250 juniors for 300 total. And oftentimes you have to fill in these numbers on the outside. I kind of did it here, I think, to save time. The sophomores, 50 went to prom, 400 didn't, so that's 450 total. Sophomores, juniors, 250 went, 200 didn't, so that's 450 total. And you add those together to get 900 total students. Okay, so we want to use this table, this two-way table, to find these probabilities. Okay, so the first one is not a conditional probability. It's just a regular old probability you went to prom. Okay, so maybe pause the video here and see if you can figure out the favorable out of the total here. Right, so total people is 900. Right, there's 900 total people. And how many went to prom? That was 300. Okay, so if we reduce that, that's about 1 out of every 3 people in our little table went to prom. Okay, so now this next one says probability you went to prom given that they're a junior. Okay, so given that they're a junior, if we think about this means we're only care about the juniors now. Okay, so we're going to look at how many juniors were there total. So that's this column right here. Okay, so that's 450 total. So I'm going to read this again because I think understanding this and being able to read it is really important. So probability you went to prom given that you're a junior. So now I'm not looking at all the prom people, right? There's 300 prom people, right? We can see that adding them together. We want to look at just the juniors, and out of those juniors, right, out of these 450 juniors, how many went to prom, right? And out of our 450 juniors, 250 went to prom. Sorry, my pen is messing up here, but that's basically it. Obviously, you could reduce that to like 25 out of 45 and then divide by 5, so you'd have 5/9. So 5 out of 9 is our probability. So the probability you went to prom, given that you're junior, is different than just your probability of a prom. Okay, and so believe it or not, this next one is different, right? It seems like it's just the order is different, but now it's probability of junior, given that you went to prom. Okay, so given that you went to prom means now we are looking at just the prom people. Okay, so this back number sort of is your bottom number. So here we have 300 prom people. Okay, and then out of those 300 prom people, how many were juniors? So if I highlight them there, there's been 300 prom people, 250 were juniors. Okay, so my probability that I'm a junior, given that I went to prom, right, is 250 out of 300. So most of the prom people were juniors, is another way to say that. So if I reduce that down, it'd be 25 over 3. Sorry, my thing is, I don't know why my thing's not working here. And then divide by 5, so you get 5 out of 6. So out of all the people at prom, 5 out of 6 were juniors. All right, let's just keep doing some more examples here. So I'm going to keep the same table with the same numbers. I'm just going to do it now with some different probabilities. So there's one more given that, and then there's an and or an or, right? Which get kind of tricky, but oftentimes I think I would just do what makes sense. I know we had some formulas previously, but on these two-way tables here, I would try to just do what makes sense. So pause the video and give these a shot before continuing. Okay, so probability you did not go to prom given that you're a sophomore. When we say given that they're a sophomore, that means our bottom number in our probability is just the sophomores. Okay, so looking at the table, the sophomores are 450. Okay, and then out of those 450 sophomores, how many did not go to prom? Most of them, right? So out of those 450, 400 did not go to prom. Okay, so if we reduce all that, that'd be 40 over 45. Man, sorry for the bad handwriting. Divide by 5, that'd be 8/9. So the probability that you did not go to prom, given that you were a sophomore, is 8 out of 9. Okay, so on an and or an or, you're looking at everybody. Okay, so given that sort of changes the denominator, the here we are looking at only sophomores. Here it doesn't, there's no given that. So we were looking at no prom and sophomores. So our bottom number is everybody. Okay, so on these last two, the bottom number is everybody. All right, so from there we just have to kind of figure out the favorable part. So here favorable is no prom and a sophomore. Well, that would be these people right here. They are no prom and sophomores. Okay, so again, the denominator there is just everybody, and then this reduces to 4/9. So probability that you're no prom and you're a sophomore is 4/9. Okay, so junior or no prom, this gets a little bit harder, but you can try the formula and stuff here, but I don't think it's going to work because these are dependent events here. So what I would end up doing actually is just looking at these numbers in the middle. They add up to 900. They're everybody, the 50, the 250, 400, and 200. And then just say, each one is they a junior or prom? Okay, so we know these ones are juniors. Okay, and then as far as prom people goes, prom people would be this 50 and this 250. So we don't really have to circle the 250 twice. And then the no prom people, they don't count because they're not juniors or nope. Oh, I did that way wrong. Mr. Westphal, messed it up. Sorry. So we're looking for no prom or a junior. So, okay. So our juniors again are here. All right, juniors are here. And then our no prom are these 400 and these 200. But we already counted the 200, so we don't need to count them twice. I guess that would be like the overlap if you were doing the formula. I just found the formulas on these, especially the and one, blew up in kids' face previously. So I kind of just do what makes sense. So here's our no prom, here's our juniors. All total, if you add all those up, that's almost everybody. That's 850, right? And so that's our answer. And I'm going to, just to save some time, I'm not going to reduce it, but technically you could reduce that fraction. All right, let's do at least one more example here. Now we're going to go back to the guitar ones, and these are all conditional probabilities, and I would pause the video and give it a shot. If you really are struggling, maybe you could watch the first one and then pause, but yeah, I don't know. Give it a shot before continuing. Okay, first thing to realize is you got to find these totals along the outside. So I would add up my tan ones, which I think is 120. Add up the black ones, which is 90, I think. I always do these wrong. This one is 28, 16, and 12. And then add these ones up going this way. So it'd be 90 plus 34 would be 124, I believe. Add all those together, and we get, I have on the other side, 114. Okay, and then all total, if you add these ones or these way, it should come out to be the same. I think it's 238. Okay, so now probability that you're tan, given that you're acoustic. So your bottom thing is because if it's given that acoustic, means I only care about acoustic guitars. So right here are all my acoustic guitars. And out of those acoustic ones, I'm not looking at all of them, just out of the acoustic, which ones are tan? Well, out of these 124 acoustic, 78 were tan. Okay, and that's my probability, which again, you could reduce. So probability that you're acoustic, given that you're tan. Okay, so here's all the tan ones, right? That's 120. Again, remember, this is the bottom number. So given that we're tan, that's 120 tan. And out of those 120 tan, how many are acoustic? 78. Right? It's not all the acoustic. It's just out of the tan ones, how many are acoustic? 78. Okay, last one here. So we're looking only at electric. So I'm looking at, maybe I'll try to highlight it for you. It's this column here. So my bottom number is 114 electric. And out of those electric, how many are blue? So that would be 16. So our probability there is 16 out of 114. Okay, let's try some and or ones. Because I think the test has all the different types looking at a 2A table. And so again, I would just encourage you to kind of do what makes sense here. Pause the video, give it a shot. Okay, so on an and or, since it's no given that, we're looking at all the guitars this time. Okay, and the ones that are tan and acoustic are right there. So our probability of tan and acoustic is just 78 out of 238 total guitars. Acoustic or tan, so acoustic or tan would be all of these acoustic ones, so that's 124, plus all the tan ones, but I'm not going to count the 78 because I already counted it in my acoustic. So here's all my tan ones, but I really only have to add in the ones I haven't counted yet, which is 42, right? So that would be, let's see, 166 out of, so probability it's acoustic or tan is 166 out of 238 total guitars.